Since this part, the magnitude part of this force is same for all, we will take this as common. So the F on G is nothing but 2gm square by a square by 3 into r cap ag plus r cap bg plus r cap cg. If we add this up from the previous data, you will see that this is turning out to be 0. Now, this is what we found out mathematically. Nobody can defy this. But you can have concluded this theoretically within a matter of seconds had you considered the fact that this situation is highly symmetrical. These lengths going to be the same. The resolution of this force in this direction is going to cancel off because of these two masses. The only forces that remain is in the vertical direction. But again, if you resolve this force in this direction, this force in this direction, the summation of that force you see is balancing of this force. Hence the net force is going to be 0. Or due to a highly symmetrical situation, we can directly conclude that the force on the mass at G due to all other masses at the vertices is going to be 0. Till now we have considered forces on masses only. Let us now look at solid objects. Say we consider a sphere. A sphere can be considered to be made up of infinite spherical shells. These spherical shells will together constitute a sphere. If we want to look at the interaction between spheres or a sphere and a point mass, we need to consider this. Before we consider this, let us look at the force on a point mass due to a thick spherical shell of mass m. Say we have a shell like this. This has, say, a thickness T and a mass m. Say we have a point mass m1 situated at a distance r from this spherical shell. To find this out, let us assume a sphere of mass m plus m dash. This m dash fills up the empty space between. So this void is now filled up. That sphere is now made up of infinitely many spherical thin shells. When we go down the line and reach the center, we are now left with a point mass. The force due to that point mass onto this mass m1 is going to be nothing but the force that we considered earlier, which is Gm m1. This m, let's say, is m2 goes down at the center, m1 by r square. This is if we consider a point mass here. To make an analogy with this, let us consider that this extra mass what we added is a negative mass, or we have this sphere. This sphere is made up of this thick shell plus another sphere. So if we consider this minus this, we get this. So the force due to this will be nothing but gm plus m dash by r square, which will be equal to the force that we are supposed to find out, plus due to this it will be, there will be m1 here, gm dash m1 by r square. Thus this gives us a force gm1 capital M by r square. So it really does not matter whether there is something here or not. The only thing that matters is the mass of this sphere or this shell and the point mass here. Note that this can be also proved, or this can also be stated logically. Say this, we consider a small mass dm at any point on this sphere. There will be a component of force. The force from the interactive force between this small mass and this mass m1 is going to be along this line. Now the force will have two components, one which is along this line and one which is perpendicular to this line. The force which is perpendicular to this line gets cancelled off by many such small masses. The only force that remains is the force of the line joining between these two masses. Hence, we get something of this form. This concept of negative masses can be applied in various such situations where we do not have the result to it directly, but can obtain by applying a similar concept. Now let us look at the force inside such a spherical shell.